Hello. Today we're going to focus just on actually writing the proofs out and what needs to be included. But keep in mind, for any of our congruency cases, you need at least 3 pieces of congruent statements before you can make a congruency case. Those congruency statements have to be listed in the proof first before the congruency statement at the end. So always make sure you use those diagrams, determine your case, and then really work on making sure you have all 3 congruency statements before you make a case for congruency. Okay, let's go ahead and take a look at these notes, okay, where we're setting this up. So again, just a couple helpful hints, okay, as you begin writing these proofs out. Okay, always start by marking up the diagram, okay, to determine what case could be used for congruency. Okay, you want to find out if there's any other pieces of information that you need to know to get to that case once you're on your diagram. Okay, then specifically be careful of the order in which you place the statements in your proof. Remember, a proof has to be written in a logical order, so we want to kind of be careful with that. And the proof should end with you stating the triangles are congruent by one of our cases. So that triangle congruency statement is going to be that proof statement that you have set up. Okay, so let's go ahead and take a look here at what that would look like if we were actually writing out a proof. Okay, so again, in this case, let's mark what we know on the diagram to begin this. So we know that OM is perpendicular with LN. Okay, well, if you have perpendicular lines, you're going to have right angles that are formed. Now you could mark your right angle at any location, but I'm going to mark it on both sides because that's a right angle in each one of those triangles that's up there. Okay, then my second piece of information is that OM bisects angle LON. Okay, so here's L to O to N. If that bisects the angle, it's going to divide the angle into 2 congruent parts. Okay, so there's my 2 congruent parts. And then I should recognize that on the diagram, we do have a shared side. Side OM is shared between the 2 triangles. So by what I've actually marked on here, I should see that we have a case for angle, side, angle. I just need to make sure that I can write that out within the steps of the proof. And I actually have 3 congruent statements. I should have 2 sets of congruent angles and 1 set of congruent sides before I can make that congruency statement. Okay, so let's look at actually how that would be written out. Okay, well, the first piece of information or the first step of the proof is always going to be our given information. And here the first given piece was that OM is perpendicular to LN. Now, if they're perpendicular, okay, they're going to form, okay, right angles in this location. Okay, I know those are right angles because that is the definition of perpendicular lines. Okay, if your lines are perpendicular, they're going to form right angles. Now, what we should know, okay, here, if I'm going to add in a third step, I now need to say that angle OMN is congruent to angle OML. 1, because I have to have a congruency statement for those 2 angles, but I know right angles are always congruent. Okay, that's your right angles congruent theorem, or right angles are congruent. Now, step 4 told us that OM bisects angle LON. That's my second given statement in this proof. Now, if we have a bisector, it will divide okay, those angles or this angle into two congruent parts. So that would then be our definition of an angle bisector. Right? And kind of the clue again was that we used that vocabulary term there, bisect. So when you use a vocabulary term, you're going to use that within your reasons. Kind of make that follow. That's the determination we're making. And then, notice I have my reason here already. Congruence of segments is reflexive. Well, remember, your reflexive property is when something's equal to itself. So we look for that shared side on that diagram. So that's going to be side OM congruent with side OM. Okay, at this point then I should be able to write my triangle congruency statement because I look back here and I should see that I have two sets of congruent angles, one right here and one right here. And I have one set of congruent sides. If I have those three congruent statements within the proof, I'm ready to write my congruency statement. Okay, so here in step 7, we say that triangle OML is congruent to triangle OMN. OML, which is right here, is congruent to OMN. Okay, and that would be by angle side angle. Now, in this case, I could have just written it like this statement here, but if I had done that, it didn't match up with the proof statement itself that OMN is congruent to OML. We just switched those around. So you can use your symmetric property to switch that, okay? Or you didn't even really need to write in step 7. You could immediately have gone to step 8. But in this proof, we're filling in parts. So it's very important for us to know why, logically, okay, one step follows to another. So just kind of careful, okay, with how that's set up. Make sure you have a reason for what you're doing. So really look at what's being said and the order in which those proof steps are set up. Okay, let's try another. And with these next two, it might be a really good idea if you just pause your video, try to write out the proof yourself, okay, and then see how it matches up with mine. You get better at the proofs by practicing those. And again, for your triangle congruency, you always have to have 3 congruency statements first before you get to your triangle congruency statement. So just kind of follow that pattern. Okay, so pause here if you would like to, okay, and then go back to see how we wrote these two out. All right, in number 2, we have LM congruent to PN, and that LM is parallel with PN. Okay, well, parallel is going to give me, okay, that's my transversal, a set of alternate interior angles that are going to be congruent. So I'm going to go ahead and mark those there. And I also notice we have a shared side. So that will be another thing that I can mark on here. And then I should see that I have side, angle, side. And that's one of my cases. Okay, that angle is included. It's between those two sides. Okay, that's important that it's in that order. So if I needed to write this all out on my own, I would immediately start with my given information because this is a proof. So we've got LM congruent to PN. I'll probably make step 2 then LM parallel with PN. Now, since the lines were parallel, I then have alternate interior angles that are congruent. So my next step here would be the angle L to M to P is congruent to angle M to P to N. And again, those were alternate interior angles. So I can use that alternate interior angles theorem, okay, to show that those are congruent. Then if I look at my picture, there was one more thing that I assumed here would definitely be true, and that's that shared side. So PM would be congruent with PM. And there's my reflexive property, okay, because that's that shared side is equal to itself. And then I take a look. I have my 3 sets of congruency statements. So as long as I have those 3 sets that match up with the parts I needed for the SAS case, I'm ready to write my proof statement. So step 5 is going to be that triangle PLM is congruent with triangle MNP, and then that was by our side angle side postulate there. All right. Again, number 3, if you want to try this first, try it. Okay, pause your video, try to work that out, okay, and see how you do. Because again, practice or try with these proofs when you're setting them up. Okay, but let's take a look. LA is parallel with SN. Okay, so parallel again is going to give you a transversal between those parallel lines. And in this case, we should see those alternate interior angles again, because one angle is below and one's above. Now, I can also see in this picture that at R, I've got vertical angles. And I'm also told that R is the midpoint of LN. Well, a midpoint is going to divide that into 2 equal parts. And then what I should notice I've got is an angle, a side, and an angle. So I want to use case ASA. Now in this case, if you try this out yourself, you may also have noticed that we could have used this as the transversal, and there's alternate interior angles here. So you might have used angle, angle, side, okay? And that would have been perfectly okay to prove it, because those are both, okay, sets of angles that can be shown congruent within this diagram. So 2 legitimate ways to prove that out. Okay, I went ahead and marked it this way, so we're going to do ASA. Okay, so again, step 1 should be my given information. And I'm using just that first statement of parallel lines, because if I'm going to make a determination from that, I only want that one there, and then I immediately want to list what I can determine. Because those lines are parallel, I can say, okay, that angle L here is congruent to angle N, because those are alternate interior angles. Okay, then I'm going to go to the second given statement. Now, R is the midpoint of LN. That was given. But I can determine, or I can write a congruency statement from that. If I know R is the midpoint, it will divide that side into equal parts. So LR will be congruent to RN. And I know that because that's the definition of a midpoint. Okay, and again, your clue, when you use that vocabulary term in a step, you're probably going to use that as a reason. And then I looked to see, was there anything else that I determined from the diagram had to be true? Now, I said that angle L to R to A was congruent to angle S to R to N. And I said these were congruent because these are vertical angles. So you can write vertical angles are congruent, okay? Or we looked at that as our vertical angles congruent theorem. And then I'm ready to make that proof statement because again, I have 3 congruency statements for those parts. I should have 2 sets of angles. So angles, angles. Then I should have 1 set of sides and they fall in that order. So I'm ready to write my congruency statement. So triangle LAR is congruent to triangle NSR by our ASA congruency case. Okay, so we can label that just as ASA. Again, just take the time to kind of practice with it, but also a good idea to try now to write the proof out on your own. Okay, a lot of problems in your homework set will be picking out a reason or picking out a step or looking with one part, but we do want to get to the point where we could write that proof out on our own. All right, good luck with your assignment here with your proofs, and hopefully they're getting a little bit easier for you to work with.